Let's talk about how a host gets an IP address. There are two ways, especially in the older time. You have to talk to the system admin first. System admin is going to give you the IP address. And then you manually type up the IP address at the specific place in an operating system. Now, how you do that can change from operating system to operating system. Where you do it exactly could also vary within the operating system from version to version. And some of you might need to reboot the machine as well in order to have the IP address taking effect. So this process here, the manual approach, very tedious, out of fashion. More fashionable today is to run DHCP, the Dynamic Host Configuration Protocol. What it does is to get the host and IP address automatically and configure it automatically. The service is entirely plug and play, so there's no manual effort required. Really nice. And we're using it every day. This DHCP protocol is already part of the protocol stack and part of the operating system. Part of all the operating systems these days, including the mobile phone operating system. So, formally, let me introduce DHCP. It allows us to acquire IP addresses dynamically. So what happened there is that our side of DHCP is running the client process. The subnet you'll be joining, the server process is running on the subnet, running on one machine on the subnet. So the two sides, client server, will negotiate and reach an agreement. So that agreement is actually a lease on a specific IP address. And that's why my host here gets to use a specific IP address. So with this, we bypass needing to communicate with the system admin, a real person. And the assignment is also automatically done because it's all part of the operating system. But essentially, after the negotiation, we get to use an IP address. But as you see here, it's a lease, meaning the IP address is also temporarily allocated. So that is why it's called the dynamic host configuration process. It only runs for a while. If you leave the subnet, this IP address will be reclaimed by the server. But don't worry, as long as you stay in the subnet, stay connected, stay on, then you get to reuse the IP address. And this is done by exchanging messages again between the client and server. So there are some more messages being exchanged and periodically so that we could renew the initial lease. So that is generally how the DHCP works. You see, this is really, really nice for us in living now a very mobile lifestyle. And the process is very simple. This negotiation process is very simple. A very simple four-way message exchange. And an even simpler version is just two-way exchange. So these two first messages, they can be actually bypassed if the user is coming in and out really fast. Typically, the OS on a smartphone implements more this version of DHCP. Now let's take a look at the scenario and go through these four messages in a bit more detail. So here it is. We've used this network already earlier to explain, right? What's IP address format and what is the subnet address. So let's assume we set up a DHCP server here connecting to 223.1.2 subnet. And we carrying a laptop, running an operating system with the client process already running. So the arriving client process here, server process here. The first message, DHCP Discovery. What it does is the client asking, in a broadcast way, is any of you guys the DHCP server? So if we look into the packet, you should see the source looking like this, a null IP address. And the DHCP client is default on port 68. DHCP server, on the other hand, on port 67. Destination will be going to the DHCP server. But hey, the client doesn't know if there is a DHCP server in the first place, not to mention the exact IP address. So we're sending it to here, the broadcast IP address. A message carrying such an IP address is going to be received by all hosts on the subnet. Therefore, DHCP server, being one of the hosts on the subnet, will definitely receive the discover message. Why I address here? Yeah, this is the field to store. The IP address potentially will be assigned to the client. Now, the client has no clue, therefore, it's null. Last is the transaction ID. Now, this is actually quite critical. Usually, it looks like a random number. Okay? Different clients will actually send discover messages carrying different transaction ID. Now, these IDs are also to tell the arriving clients apart. So there could be other clients arriving as well. And they could be sending these DHCP discover messages about the same time. Servers sending responses, DHCP offers, okay, about the same time. How does this guy know which offer is for this guy, and how does this other guy knows, right, which offer is for him? So transaction ID, okay, typically different, coming from different clients to enable the clients to tell whether the reply is coming for the host or not. So very important. And to respond to the discover message, the server sends the offer message. Okay, so this is saying, yeah, I'm here. And here's an IP address you could use. And inside the offer message, you see the source being the server's IP address. Destination, again, the broadcast address, because arriving client doesn't have an IP yet, but will still receive a message going to the broadcast IP address because everyone on the subnet will receive such a message. And we see here, the server is offering this IP address to the client. Transaction ID, yep, the same pair. So this offer is for this discover message. And you see, server here, while offering a specific IP, is also saying, hey, client, you get to use this IP address for 3,600 seconds long. Okay, so it's the duration of the lease. Client then say, yeah, DHCP request, okay, I'm going to take the IP address, and this is the content. Asking for this IP address, and it's a new transaction for this long. In return, the server sends back ACK, okay, which is simply saying, okay, you got it. Okay, therefore, you see, yeah, you got the IP address for this long. And this, again, corresponds to this, okay, not to be confused with other clients requesting for other IP addresses. So this is the exchange of the four-way messages in DHCP service. Now, in the exchange, DHCP server actually say more, okay, not just the IP address, but a whole bunch of other things that are very critical setting up, okay, the subnet on the hosts. So first is who the first hop router is, because the host message going out onto the subnet, the default next hop is always the first hop router, because the first hop router then, after picking up, then can determine where else to forward it further. Another important information, yeah, DNS servers. This is very critical, right? Because you're requesting www.google.com or www.something something, okay, by the name of the server. Okay. In order to know the IP address, you also need to configure on your host the DNS servers. I know some of you might have some DNS server IPs assigned already, configured already, but if you connect to DHCP server is going to also, okay, add some IP addresses into that part of the operating system. Okay, so the name and the IP addresses of some DNS servers by default. And then the network mask. So this is to tell the host how long is the subnet part of the IP address. So provided the IP address, the DHCP server is also saying that, hey, what is the subnet part? And therefore, okay, the client also knows what is the host part. And to illustrate, you see in this DHCP example, yeah, host is right here. Okay, we just joined. And DHCP server is already up, and it happens to be running on the first hop router. So what happened there is, yep, the connecting laptop is going to send a DHCP request message out to the network. So this is the simplified version of DHCP. Sending request and server sending ACK. So the laptop here is asking for its IP address. In addition to that, yeah, first hop router, DHCP server, and netmask. So DHCP is actually right here, an application layer protocol. And yeah, that DHCP discover or DHCP request message is going to be what? Passed to the UDP and adding the UDP header, push down to the network layer and adding the IP header, and push down to the Ethernet and adding the Ethernet header and trailer. So the DHCP request gets encapsulated into an UDP packet, further into an IP packet, further into an Ethernet frame. So you know DHCP is actually implemented at the application layer. Yeah, just like DNS, seemingly a lower level functionality, a general functionality, okay, for everyone on the internet, but implemented at the application layer. Complexity at the edge. And it's using UDP as the underlying transport layer service. Now this frame, okay, carrying destination address being broadcast 255.255 all the way, is going to reach all the hosts on the subnet. So this is the entire subnet. By the way, this is an Ethernet switch. It's a rectangle, not quite a circle. So this is not the router. Okay, so yeah, this is actually the link. Okay, so this interface and this interface are connected through this link. So every host on the subnet is going to receive the DHCP discover message. So therefore, the server here is going to pick it up. So this is what going to be extracted, okay, and pass up to the IP layer. This extracted, pass up to the UDP, and this extracted, and eventually reaching the application layer. So the server then can see, this is a request message, therefore send back a reply. So you see here, going all the way, Ethernet gets demuxed to IP, to UDP, and finally, server side of DHCP. Now, the server then will generate the ACK message containing the IP, containing the IP address of the first hop and the IP addresses of the DNS servers, and so on and so forth. So, process is very similar, encapsulate to UDP, encapsulate to IP, Ethernet, and destination address being broadcasted. Yeah, the host here, although not having a specific IP address, is going to pick it up. Okay, so client now knows the IP address of itself, name and IP address of the DNS server, and the first hop, as well as what? The network mask. So what I'm showing here is the result of sniffing DHCP messages. This is a DHCP request message, and this is a reply of that. Earlier, we actually called it the ACK packet, okay, ACK message. And I can use tools like Wireshark or TCP dump to sniff packets travel the internet. Now, after sniffing, you're gonna see the content inside the packet. So what I'm showing here is, yeah, this is the request message. So you see boot request, and in the reply or in the ACK message, you see it says boot reply. And you see transaction ID, yeah, transaction ID, and they're identical. So this ACK here is for this request. And then you see also specifically the client not having an IP address, but it still have a MAC address. So that MAC address is actually hard-coded into the network interface card that came with your machine. Okay, so that is already existing. And that is something that the DHCP client is going to send to the server. So server can identify you somewhat by the MAC address. And then, yeah, this is DHCP request, okay, and this is DHCP ACK. And the client is asking for these, right? So the IP address, okay, so IP address is not clear yet, so requesting, yeah, this IP address. Okay, so this is not a sure thing. It's just that the client suggesting, can I get this IP address? And it's also asking for, yeah, domain name servers, and the subnet mask. Server here, yeah, in the response, it will see, okay, hey, client, okay, it's okay to use this IP address. Go ahead. In the meantime, it's returning also the subnet mask, yeah, the first hop router, as well as the IP addresses of the DNS servers and the domain name. See, all these information, client can then set everything up and then begin to access the internet.